Back in 2018, a paper dropped from a team at Google AI, and it didn't just make a ripple in the world of artificial intelligence, it made a tidal wave. It completely changed how machines understand our language. Today, we're diving deep into that paper and its legendary model, BERT.
It all comes down to this one question, right? It sounds simple, but it's incredibly profound. How does a machine go from just seeing a bunch of letters on a screen to actually getting the context, the nuance, the real meaning of a sentence? For years, this was the central puzzle of natural language processing.
You see, before BERT showed up, language models had a pretty serious blind spot. They were definitely getting smarter, but they all had this fundamental flaw, this sort of one-way vision that was holding them back in a big way.
And this slide gets right to the heart of it. Think about it. Older models, like the early GPT from OpenAI, read a sentence just like you're reading this now, from left to right. To figure out a word's meaning, they could only look at the words that came before it. BERT's huge breakthrough was that it learned to read the entire sentence at once, looking forwards and backwards at the same time to understand the true context of every single word.
And hey, don't just take my word for it. The authors of the paper knew exactly how big a deal this was. They don't pull any punches here. They state, flat out, that this one-way street was a major limitation. They even called it suboptimal. This was the very dragon that BERT was designed to slay.
So, how did they do it? How did they fix this one-way vision problem? Well, this brings us to the core genius of BERT and its absolutely revolutionary approach to seeing the whole picture.
And here it is, the star of the show, BERT. It stands for Bidirectional Encoder Representations from Transformers. Now, transformers are the engine underneath, a super powerful architecture. But the absolute key word, the magic word in all of this, is bidirectional. Its whole reason for being was to learn language by looking at both the left and the right context, all at once, from the ground up.
But okay, how do you teach a model to be bidirectional? That's the real trick, isn't it? Well, the researchers came up with two brilliant and surprisingly simple ideas. First, something called the Masked Language Model, or MLM. And second, a task called Next Sentence Prediction, or NSP. These two together are the secret sauce.
So let's pop the hood, shall we? We're going to see how these two ideas work together in this elegant and incredibly powerful two-step framework.
First, there's pre-training. This is where BERT just sits down and reads a truly colossal amount of text. We're talking the entire English Wikipedia plus a huge collection of books. It's not trying to do anything specific, it's just learning the rules and patterns of language using those two special tasks we mentioned. Then, you get to step 2, fine-tuning. You take that super smart pre-trained model and you quickly teach it a specific job, like answering questions, using just a tiny bit of specialized data. It's an incredibly efficient system. Now, that main training trick, the masked language model, it's actually inspired by something you probably did in grade school. Remember those fill-in-the-blank worksheets, where you have to guess the missing word in a sentence? That's called a cloze task, and it's the core idea behind how BERT learns.
So, the process starts with a perfectly normal sentence, something it found in that huge library of text it's reading. For example, the paper introduced a new model called BERT.
And here's the genius move. The system randomly hides or masks about 15% of the words. So our sentence becomes, the paper introduced a new model called mask. Now, think about it. To have any chance of guessing that the missing word is BERT, the AI can't just look backwards. It has to look at the full context. This simple game forces it to develop that deep, two-way understanding of language. It's so clever. The second task, Next Sentence Prediction, is just as easy to grasp. The model gets two sentences, A and B, and just has to guess, is sentence B the actual sentence that followed sentence A? So, for example, A, the man went to the store, followed by, he bought a gallon of milk. Yep, that makes sense. But for B, penguins are flightless birds. No. This teaches BERT how sentences relate to each other, which is super important for more complex stuff like understanding paragraphs. So, you've got this new bidirectional approach, trained with these really clever tasks. The big question is, did it work? Well, let me tell you, the results weren't just an improvement, they were a demolition. The researchers took BERT and unleashed it on a whole battery of standard language tests. And the results, well, stunning is honestly the only word for it. BERT didn't just raise the bar, it launched the bar into a different orbit.
Let's just look at the raw numbers. On the GLUE benchmark, which is a tough collection of 9 different tasks, the big version of BERT hits a score of 82.1. Now look at the competition, even OpenAI's GPT. I mean, it didn't just beat them, it absolutely crushed them. A 7-point jump on a benchmark like this is practically a miracle. It's a massive, massive leap.
And it wasn't a one-trick pony. Over on the Stanford question-answering dataset, SQUAD for short, it was the same story. The previous best score was a 78. BERT comes along and posts an 83.1. That's a 5.1-point jump. Again, in the world of AI research, getting that kind of improvement from a single new model is it's almost unheard of.
11. That's the number. When the dust settled, BERT had set a new, state-of-the-art record on 11 different NLP tasks. This wasn't a fluke. This was a fundamental shift in what was possible.
But BERT's legacy isn't really about the high scores. It's about the core ideas it proved, principles that have guided pretty much all AI research ever since.
So what did we learn? First, it proved beyond a shadow of a doubt that deep bidirectionality is king. Seeing the whole context just works better, period. Second, it pretty much ended the era of building custom one-off models for every little task. Why would you when you can just fine-tune BERT? And third, it showed us that scale matters. Making these models bigger and feeding them more data leads to jaw-dropping improvements.
And really, the authors themselves said it best. Their biggest contribution was showing that a single, pre-trained bidirectional model could be the foundation for solving a massive range of language problems. It was a unifying theory for the field.
BERT was a monumental leap forward. It taught machines to truly understand the context of our language in a way we never thought possible. And it laid the foundation for the incredible AI we see all around us today. Which, of course, leaves us with a pretty wild question to think about. What happens when they start understanding context even better than we do?